We are going to talk about adding and subtracting polynomials, okay? And you're looking at this big, huge writing here, and you're like, what is this? All right, so what I'm wanting to talk about is one term, a single term of a polynomial, what that looks like and what these parts are called. All right, so the 2 here is called a coefficient. Okay, it's called a coefficient. The x here is called the base. And the 3 here, as you know it, is called the power. Sometimes you call these the exponent. Interchangeable, okay? So, why I put that out is because in order for you to add or subtract polynomials, you have to have like terms. Okay, and what are like terms? Like terms are same base and same power. Okay, so if you don't have the same base and the same power, then you can't add them. But if you do, then you can. And that's all really is with adding and subtracting polynomials. That's where the biggest mistakes are made, is because they don't remember same base, same power for like terms. Okay, so, and the way I look at terms is that with variable, when you look at the variable, if it's an x, it's a certain fruit, right? If it's an x, it might be a banana. But if it's an x squared, it might be a plantain. If it's an x cubed, it might be, I don't know, an orange, right? And if it's a y, it would be a pear. If it's a y squared, it'd be a watermelon. If it's a y cubed, it'd be an apple. Okay, I'm gonna start running out of fruits that I know. All right, so different base and power coordinates with, like, let's say different fruits. All right, so let's look at a problem here. So example, wow, that was nice, E. All right, so let's do this one right here. It says negative x squared plus 7xy plus 4y squared minus x squared minus xy and then plus 6y squared. So what you want to do is make sure that you are seeing the same base and same power. That's number 1. Number 2, always take the symbol in front of that coefficient or variable as the value of it. And you're like, what do you mean? You're speaking Chinese to me. And I do speak Chinese, by the way. All right, so here's an x squared. And here's an x squared. But they're not just x squared, they're actually negative x squared. Negative 1x squared, really speaking, okay? Then let's see here, I'm gonna take this one. So these are both xy, right? X to the first power and y to the first power, x to the first power and y to the first power, right? The value of this one is positive 7xy, while this is a negative 1xy. All right, then let's take a look at that one. All right, let's try again. There we go. And there it goes. Y squared, positive 4y squared, positive 6y squared, okay? So now I can add them. Now I can go, okay, so this is a negative 2x squared plus a 6xy plus a 10y squared. I hope that you guys see that, okay? And the xy is 6 because this is a 7 minus 1 xy. Okay, so remember how I said it's like fruits, right? So let's take a look at the xy. So if I have, and xy would be a fruit. Let's call xy as a exotic fruit like star fruits, right? So if I put 7 star fruits in my basket and I take 1 star fruit out, then I have 6 star fruits left. So what I'm saying is that if I look at just the xy as label for the fruit, right? So 7 star fruit minus 1 star fruit equals 6 star fruit, right? But typically what people like to do is say, oh, I'm just going to have this as x squared y squared because it's x plus y, you know, xy and xy. Well, now x squared and y squared might be a totally different fruit, right? So that's the reason why it wouldn't be x squared y squared, because that becomes a totally different fruit, which doesn't make sense in real life if I had 7 star fruits minus 1 star fruit and I'm now having 6 kumquats in my basket. It wouldn't make any sense. All right. So that's the way I want you to look at it as you're doing this. Boom, 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 boom. Oop, oop. There we go. All right, and therefore that is my answer right there, just like that. And that's how you combine like terms. Now, you might get problems like this, however, with parentheses. So you might get something like this: 6y squared minus 8y plus 5 minus a 7y squared minus 8y plus 9, okay? So you might have a subtraction in between. So, and in front of this parentheses, since there's nothing, it really is just a positive 1 that's in front, okay? And if I distribute this 1 through, I'm just gonna get itself anyways, okay? So I want you guys to understand that. That's why I'm not going to do anything with the first parentheses, but I am going to do something about the second parentheses, okay? So, yes, I still have to distribute this negative into all 3 terms in that parentheses, okay? So what I essentially have is I would write the first set of parentheses just as is. In the second parentheses, when I distribute that negative, it basically flips all the signs inside. So notice that how the 7 was positive became a negative, how the 8y was negative now became positive, and how the positive 9 became a negative 9. Okay? So now I can go, okay, let's add this all together. And notice how all the like terms are aligned. So this is the up-down method. That's certainly fine. You're welcome to do that. What do I have left? I got a negative y squared. Ooh, negative 8y, positive 8y, that goes away. And then a minus 4. So I have negative y squared minus 4. So that would be my answer. Okay. Not too shabby. What else is there? And that is, oh, I was going to do a distributed problem. So, example. So, if I had a negative 3, actually, times 3z minus 6y, okay? So, it just means I have to distribute a negative 3 through, okay? So I'm going to write this out, okay? So this is going to be negative 3 times the 3z, negative 3 times a negative 6y. Okay, that's essentially what distributing means. So what do I have? I'm going to have a negative 9z plus 18y. Now, can I add these two things together? What'd you say? I didn't hear you. Say it again. That's right. No is the answer. You cannot combine these two because they're different bases. One's an x, one's a y and one's a z. So they're totally different. So therefore you cannot add them together. All right. Well, this is the end of the notes. I hope you had some fun and hope that helped you.